Okay, so we are, like I said, it's just a recap of your primary school work. Square, rectangle, triangle, circle, length, perimeter, and area. Okay. So for square, do you need me to go through? Oh yeah, don't waste your time. Square. If the one side is 15, area, your square. If I tell you the area, all you need to do to reverse to find the length will be the square root. Okay, rectangle, so triangle. Okay, triangle. Realize that a lot of students have a problem finding area of a triangle. Does it shock you? Okay, now, anybody not confident about finding area of triangle? Anybody not confident? Let's take a look. Area of triangle equals to half base and perpendicular height. Right? We all know that. For a triangle that looks like this, 3 and let's say 4, we can find this area really easily, very confident. Area equals to half times 3 times 4, and we get 6 square units. Simple. But what if the triangle looks different? A triangle that looks like this. Okay, so A, B, C. How do we find the area of this particular triangle ABC? What information do you need? The height. Where is the height? From the topmost to the bottommost. So am I right to say that the top, this is the top, down to the bottom? Is this the height? Perpendicular. So this way. And what else do you need to do? You need to extend AB, isn't it? So this AB will be our base. And this will be our perpendicular height. Can? But what about another triangle? A, B, and C. What about this particular triangle? How do we find this area? What information do you need? This is not a right angle triangle, so what information do you need? Height again. Where's the height? AC. Is AC the height? Is this the height? Height? No, right? That's not the height. Where would the height be? Do you know that for triangles, to find the area, you need to first identify the base? Have you decided where the base is? For all these triangles, the first two examples, do you notice that you were already assuming something? When you were doing when I asked you to calculate the area, in your mind, you were already assuming something. I don't know whether you realized it or not. You already assume that the horizontal distance is the base. Must that always be the case? Must the horizontal distance always be the case? Must the horizontal distance always be the base? No, doesn't have to be. You can rotate your paper around. The horizontal may not stay as horizontal. So when you have this particular triangle in red, where is your base? You have 3 options. Okay, stop talking at the back. You have 3 options over here. The reason I'm going through this primary school work is because many students don't know how to find the base and the corresponding height. They seem to have the impression that a triangle only can have one base. But I'm telling you that a triangle can have 3 different bases. They will have, as a result, 3 different perpendicular heights. So this is the triangle which I'm going to duplicate. Let me try and duplicate this. Copy. Paste. Okay, that's one. And then another one. Okay, I've got three same identical triangles here now. I think most students prefer to use BC as the base. So if this is the base, this is how you find the perpendicular height. The point that is not used, I've already used BC for the base. The point that is not used is A. From A, you drop a perpendicular down. Your set square has a 90 degree. Your ruler has a 90 degree. All I need to do is take your 90 degree icon, whether it's a ruler or a set square, and place it one straight edge up on the base. See the straight edge, it can be anywhere here, right? The other straight edge touching the point. You see that? Once you do this, you have your perpendicular height. Okay, one more time. Once you decide the base, you have to decide the base first. Then the point that is not used for the base, which is A, drop a perpendicular down. You can do so using a set square or a ruler. Do not depend purely on your own sketch, because we're not very used to drawing 90 degrees yet. Until a time when you're very confident, you've got a lot of experience, you can do so without the set square or a ruler, then you carry on. But for now, use a set square or your ruler to draw. In the first case, we have this as our perpendicular height. In primary school, you learn half times base times height. I am introducing an extra word, times perpendicular height. Perpendicular is crucial to getting the answer. Okay, so now in the second example, same triangle, three different bases. Let's choose AB as our base. If I choose this as the base, then where's the perpendicular height? We start from the point that is not used. Can you find the point that is not used? Which point is it? Point C. I need to drop a perpendicular down to the base. Okay, I'm gonna make it smaller so that at least my set square has a chance of fitting. Okay, so same set square, I'm gonna one straight edge of the set square on my base. So a bit harder to see now. Okay, on the base. So my set square can be anywhere on the base. But I need the other straight edge to be touching the tip. So this results in this. You see that? With the set square, it allows you to extend the line mentally by sliding your set square. You slide until the other line touches the unused point. Slide until you touch. Stop. Draw the total lines. This will be your perpendicular height. Okay, so what is going to look like? Got it out. Perpendicular down. And finally, last side that is not used. If this is my base, it is the same triangle. The point that is not used is point B. Place your protractor. Okay, too lazy to walk already. Visualize the protractor is placed on the base. We're going to slide until it touches point B. Slide until it touches point B. So we will have to extend our base. perpendicular down. This will be our corresponding perpendicular height. So for a triangle, we always have 3 possible bases corresponding to 3 different perpendicular height. But the formula is the same, half times base times corresponding perpendicular height. And it will give you the same answer, although your bases and your heights are different. So that's for our triangle. This idea of perpendicular height, very crucial. We need it for parallelogram, trapezium, rhombus later on. Okay, so that was for our triangle. This is a very simplified example. Okay, do you think we're going to be testing you area of triangle, or are we going to give you this kind? It's lagging. Most likely, we are going to give you this question. And we're going to give you, most likely, certain information only. For example, I'm going to give you this distance. I give you, let's say 3. And then I give you all the other lengths of the triangle. Maybe this will be 4 cm, 8 cm, and 10 cm. Then you will have to decide, well, if that 3 is given, what then should I be using as the base? You will have to decide for yourself. Okay? So the next shape that we need to know will be our circles. Circles, as you have shown me last lesson, you remember the formula. Pi r square for area and 2 pi r for our circumference. Anybody has a tendency of mixing them up? Sure have lah. At least, at the very least, memorize pi r square and 2 pi r. Pi r square, 2 pi r. If you cannot remember which is for which, here's a trick that I have for you. Pi r square versus 2 pi r. Let's talk about units. Pi is a constant. It is a number. It has a value of 3.14, blah, 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 blah. Does it have units? Does pi have units? It's like saying, does the number 1 have units? No, number 1 is just a number 1. There are no units over there. No units. What about the r? What does r refer to? Radius. Does radius have units? Radius has units. It is the length. It refers to the distance from the center of the circle to any point on the circumference. R, radius, has units. What is an example of units for R? Example, cm. Okay. What happens when you square a cm? Oh yeah, cm square, right? When you square the cm, you get cm squared. You end up with square centimeters. And what do you think I'm trying to get you to realize now? Square centimeters has to be for area, and therefore this is for area. If this is for area, the other must be for a length. Let's double check. 2 is a number. A number 2, no units. The number pi, it is literally a number, no units as well. The letter R represents radius. Radius has units. Example will be cm. So we put them together, you get units of cm, and it corresponds to a distance, a length. In this case, it must be the circumference. Did you realize that? We can confirm it, no? Let's look at for a square. Side times side. If one side is 3 cm, the other side being 3 cm as well. When you multiply them together, you get area equals to 3 cm times 3 cm. This is me putting down all the units. Treat it like algebra. 3 times 3 gives us 9. Treat it like algebra. Cm times cm gives us square centimeters. Okay? Same thing for your rectangle. And let's try the interesting one for the triangle. Half times base times perpendicular height. What are the units for half? No units. Half is just a number. No units at all. What about base? Base has units of cm. Height, units cm. Multiply them together. We are going to end up with square centimeters. That is the unit for area. Likewise for circle. That is why I say at the very least, you need to memorize pi r square and 2 pi r. If you're confused over which is for which, you can easily do a mental exercise. R square, cm square, area. Next thing, in our maths question, unless the question tells you to use pi equals to 3.142 or any other value, in a very rare occasions, they may say use pi as 22/7, which is a horrible estimate. Very horrible estimate. Unless questions say you will not use it. The default is calculator value of pi. Can you find pi in your calculator now? Or press. What is our calculator pi value? (3.14159264). Anybody's calculator goes beyond that? Is there any model that goes beyond 2654? No, none. Okay. So, as your calculator showed you, it is simply a number, nothing to be afraid of. But what kind of number is it? Remember in our first few weeks of school? Recurring. Is it recurring? Recurring means it repeats itself. Does it repeat? Are there any numbers that repeat? Don't have. So it is irrational. This pi is an irrational number. It goes on forever. So at this point, I'm doing a quick revision. It will be useful for you to write down in your notes, whether it's your hard copy notes or your iPad. Write down, this is an irrational number. It goes on forever. The technical term is non-terminating. It goes on forever. It is non-terminating. This is the first point. The second point is that it does not repeat. Okay, 2 points for irrational. Goes on forever, does not repeat. Another example would be your square root 2, square root 3, 5 times of square root 2, etc. Okay, these are irrational numbers. So with that, you should be able to continue the questions in this set of notes. So the length of breadth and breadth, 40 and 10 cm respectively. A square of side y, a square of side y has the same area. Find the area of rectangle. Okay, simple. Area of rectangle 400 square centimeters. Area, form an equation in y, solve for the value of y. Area is same. So y times y, giving us y squared must be 400. So y equals to 20. All you had to do was to take square root of 400. So calculator will do that for you. Perimeter, this one is just insulting your intelligence. I'm sure you can do that. Okay, question 2. So although we say that these are primary school concepts, your area and your perimeter from a circle, square, rectangle, triangle. We are of course going to fix in some algebra for you. So length of rectangle is 3 times the width, x. Important thing is for you to translate. It is like translation from a language to another language. So the width is x, the length must be 3x. Immediately, you should be able to write that down. Then, okay, so that's given. And they say the perimeter is 144. Don't be afraid. You can do perimeter questions. If you can do perimeter questions, you can do this if your algebra is all right. Sketch. This is x, 3x, 3x. What are they trying to tell you? Perimeter is 144 centimeters. Where is the perimeter? Trace it out. 3 cm, 3x plus x plus 3x plus x. That is the perimeter, right? If I were to add all of them up, I should get 144. What happens if I add 3x plus x plus 3x plus x? How many x's altogether? 8 of them. 8x equals 144. 1x must be, and you divide both sides by 8. Once you have the x value, you can continue to solve. You want the area. So area must be length times breadth. The length being 3x will be 3 times 18, because x is already 18 times 18. You get the answer. Okay, next one. Was this covered in the video? No. Okay, then you all need to look at it. Okay, so for triangle, I like to put in perpendicular height. Half times base times the perpendicular height. So these are the three different examples. If we were to find out the areas for all of them, using the same formula, realize that even though they look different, the areas are the same. Half times 4 is 2, 2 times 5 is 10. So 10, 6. No, sorry. 6, 6, and 6. Okay? They conveniently put the horizontal as the base. By the last diagram, the teacher is trying to show you that if you choose to use 5.83 as your base, then that will be your perpendicular height. If you choose to. Okay, now, from here, we know that all the areas will be 6 square centimeter. And here's the popular question. Put a star beside it. Very popular question. Year in, year out, test and test and test. Given that BC, they now tell you that BC has a distance of 5.83. Find the perpendicular distance from A to BC. You need to understand what they want. They want a perpendicular distance. Perpendicular distance, write a note over here. Put a note in your notes. Shortest distance. Perpendicular distance is always the shortest distance. Always. Find the shortest distance from A to BC. So in the same way, you can use your set square. Place one H on BC. Slide until it touches point A. That will be your perpendicular distance. That is your shortest distance. Okay, now we let that distance be H. Let the distance be H. We are going to form an equation. What has the length BC and this H over here What has this got to do with the area of a triangle? We already found the area of the triangle using other information given. It is 6. The area is 6. Now look at the highlighted portions. If BC is our base, and the letter H over there being the perpendicular height, wouldn't we also be able to form an equation for area? Half times base times height. So forming another equation, half times of BC. Okay, so the highlighted portion, BC. This is our alternative base. Okay, now instead of using just AB as our base, we have many options. We have 3 options. BC as the base. Where is the corresponding perpendicular height? Here. This is an alternative expression for the area. And we know that this value is 6. We calculated that earlier on. So we write area equals to 6. The area of 6 is equals to half times BC. Oh, BC was given to us, 5.83. Replace that. Multiplied by the unknown height. That is what they want us to find. So in order to find the unknown H, I need to do the same steps to both sides. I need to get rid of the half. How do I get rid of this half over here? How do I get rid of it? You can divide by half, okay, as shown. Or you can think of it as multiply by 2. Because when you take half times 2, you get 1, isn't it? Multiplying by 1 effectively is not doing anything. You are effectively removing half times by multiplying by 2. Okay, so both sides you divide by half, multiply by 2 is the same thing. And the next step, both sides divide by 5.83. So you would have removed both of these. On this side, it will be 6 divided by half divided by 5.83. And we get our height to be 2.06 to 3SM. This is an important question. Key concepts over here. Put stars. We will see it many times, yes. So you are saying, skip all this and say height equals to area times 2 divided by 5.83. Okay, what do you think? Exactly. If you don't know how to explain, nobody's going to understand what you're doing. Unless they are also thinking of the same thing. The sad truth is that as a teacher, I understand what you're doing, but I cannot give you the mark. You need to show us how you arrived there. So no. This, yes. Okay, so next one. In this diagram, AB 5 cm, BC 4 cm, AC 3 cm, find the area. You need to decide where's the base, where is the perpendicular height. So they gave us 3 different lengths. Quite obviously, we have to use base as 4, the perpendicular height as 3. Alternatively, use the base as 3, perpendicular height as 4. No difference. You're just multiplying the same thing. And then they want us to find the length of CD, where CD is perpendicular to AB. You see, it is the same question. It is the same type of question. If we repeat the question, if we repeat the concept in our notes, and then we make you do the same type of question in your homework, what are we trying to tell you? We're trying to tell you that it is important. You need to know this. It will be tested. So using the area, using your answer in part A, which is 6, area equals to half times alternative base. Where is the alternative base? 5. Alternative base multiplied by its corresponding perpendicular height. The corresponding perpendicular height, in this case, will be CD. Over here. So you need to continue with your algebra. Let's get rid of the half we multiply by 2. Multiply by 2. So you now it's 6 times 2, which is 12. After that, you still need to divide by 5. Divide by 5 to get rid of the 5. So we end up with 12 divided by 5, which is 2.4. Yes. Why would you want to write so many extra things? Now you have to spell everything out. Isn't it shorter this way? I get your struggle. I get your struggle. I really do. When I was a student, I struggled. So why cannot I go to sign up? The thing is, we need to be clear in our presentation. This Sec 1 work relatively simple. When we do this way, when we move on to Sec 2, Sec 3, Sec 4, you're going to have to do a lot of manipulation. You always have to start out with a formula. You quote the formula, then you manipulate. When I say manipulate, I mean doing the same things to both sides. Right now, it is a simple formula, r times base times height. There are only 3 parts to it. Number times number times number. So it is easy for you to mentally reverse everything times 2. Divide by the base. Mentally easy. When your formula becomes x equals to minus b plus minus square root b squared minus 4ac over 2a, how are you going to do it mentally? You need to do it step by step. Formulas are going to get more complex. Okay, so that was for exercise 4. And now exercise 5. It is the same type of question again, but this time they didn't require you to find the area. They already gave it to you, 28 square centimeters. But you need to learn how to understand. You need to understand what this means. This phrase, find the perpendicular distance from A. Okay, so far, okay. Perpendicular distance from A to what? From A to something, right? To DC extended. This phrase, DC extended. Where is DC? This is DC. The next word, extended. Extended. You extend, you extend. Extend both sides. One of it will be redundant lah. In this case, clearly the right hand side is redundant. Okay, DC extended. So this is our extension. They want you to find that perpendicular height, and then now it becomes easy already. So we start off with the formula again. Given formula. Area 28. Half times base times height. I know he wants to write h is just 28 times 2 divided by 7. I know. But you cannot. You need to show us the formula. Only then, on both sides, multiply by 2. And both sides, you divide by 7. To get the answer, 8 cm. Exercise 6. We got this information, perpendicular distance from C to BA extended. BA extended. You need to understand the phrase in order to solve it by yourself, in case it is not drawn in the diagram for you. So this perpendicular distance is 3 cm. Okay, find the length of AD. Same, you need to find the area by yourself first. So choose the correct base that has the perpendicular height given to you. If you didn't choose 4 and 3, you didn't, and yet instead you chose the base as 6 cm, and you try and find the area with this base, half times 6 times perpendicular height AD. Oh, you stop. You don't know what AD is, so it is useless for you to use BC as the base. Then if you decide to use the other base, let's try CA as the base. Worse, you don't even have CA. You don't even have the perpendicular height from CA extended to B. So the only option is 4, and 3 to get the area. And then from there, you substitute into the formula to get AD. Same format. Okay, so for triangles, this is probably the only special type of concept that you have learned in secondary school. Then we talk about circle. Circle questions, by default, pi, use value in your calculator. Now they tell us the circumference of a circle is 12 cm. Again, not so straightforward. Instead of giving you radius, find circumference, they gave you circumference. So you need to find the radius. The approach, the presentation is, let R be the radius. Circumference, this is our formula. This is our formula. You need to write it down. Formula 2 pi r. From there, do the substitution. 12, that is the circumference, equals to 2 times pi times r. From here, both sides divide by 2 pi. We divide both sides by 2 pi, you end up with the r value of 1.91 to 3 SF. By default, 3 SF. Okay? So reiterate, circumference, very simple formula, 2 pi r. Very tempting for you to just take, radius, circumference divided by 2 divided by pi. But I need to see the formula before you substitute. This is good practice. It is to help yourself. Get used to the habit. Next, find the area of the circle. Leave your answer in terms of pi. There are two methods that are shown over here. I have a preference, but I'll teach you both. The first, in both cases, you need to write down the area, pi r square. Question is, what is the value of r? Oh, we found it. We found that r was 3 SF 1.91 cm. For 3 SF, 1.91 cm. But is that the best value to use? Is 1.91 a good value to use for the radius? No, it is not exact. First, it is not precise. Next, it is not. Actually, it's just not precise. Okay, so 1.91 not precise, not good. You lose a lot of accuracy if you use it. Therefore, we should use 1.9099. So that is why in here we use 1.9099. And we get this value, 3.6477 pi. Because the question says leave your answer in terms of pi, we do not expect you to multiply by calculator value of pi. You just need to treat pi as algebra. Treat it like a letter A, like a letter B or an X. Treat pi as algebra variable. Just treat it like an X. Don't do anything to it, but just remember to include it. So 3.6477 pi, approximately 3.65 pi. So this is in 3SF. If you had used your 1.91, let me just do a quick check. 1.91. Maybe I'll still get 3.65. Maybe I wouldn't. Let me try. So pi r square. So don't copy this down. Whatever I'm going to write, please do not copy it down because it's wrong. Area equals to pi 1.91 squared. I end up with 3.6481 pi. And this is approximately 3.65 pi cm squared. Okay, look closely at the values. 3.641 pi versus 3.6477 pi. Are they the same? No, they're not the same, they're different. Which is more accurate? the 3.6477 is more accurate, right? I refrain from saying exact because it is not exact in the first place. Over here, where did it come from? It came from this, which was not exact also. But this is better than this. We don't want to use this because there's 1.91, very imprecise. Although the final answer is the same, 3SF. Though they are the same, but we don't want to use that. Now, this is by the not exact value method. Why is it not exact? Because we use 1.9099. 1.9099 was 5 SF, which is good enough. But is that the most accurate? No, it wasn't. It wasn't the most accurate. Because we did some calculation over here. We divided by pi. So is there a way where we can find the most exact area in terms of pi? Turns out there is. Okay, I'll be doing it over here. What did they say for the circumference? Circumference is 12. So I'll redo it. Let radius be r. Circumference is 12. So 12 equals to 2 pi r, which results in r equals to, I do it step by step, divide by 2 on both sides. We end up with divide by 2 on both sides. Why can't I erase? Okay. When you divide by 2 on both sides, you get 6 equals to pi r. Now you divide by pi on both sides. 6 over pi equals to r. Okay. You can use your calculator and find out what is 6 over pi. Yeah, of course you're going to end up with 1.9099. That is the value of r. But watch what happens. I don't want to evaluate this. I leave it like this. This is very exact, right? You know what? It is just called exact. It is not very, it is exact. This is the exact value of pi, of r, sorry. This is the exact value of r. I just did not evaluate it. You see that? 6 over pi is exact. I'm going to use this value to find the area. Area equals to pi r squared. I am now going to substitute equals to pi. What is my radius? 6 over pi. And I square this. This so far is the most exact. I did not lose any accuracy. I did not do any rounding off. I didn't even press calculator. Okay, so we end up with pi 6 over pi squared. What does that exactly mean? 6 over pi, 6 over pi. This is what 6 over pi square means. Okay, the reason why I am having so much difficulty is because this laptop doesn't have very good tracking of the stylus. It detects my finger as well. Okay, now 3 items multiplied together. I can change this into a fraction. Fraction times fraction times fraction. Numerator times numerator times numerator divided by denominator times denominator times denominator. So we get 6 times 6, which is 36, times pi divided by pi times pi. Yeah, pi square, right? But we can also cancel the pi and the pi. So my exact answer would be 36 over pi square centimeters. This is the most exact form, and I have left it in terms of pi. So compare this value, 36 over pi versus 3.65 pi. They will have very similar result. Very similar, just that one of it is more exact. In fact, this is the best. And this is not wrong, but it's not as good. You see the difference? Both are in terms of pi. It's just that one is exact, the the other is not. Yeah, okay, this is all recorded. So I'll upload it onto YouTube. So exercise 8, we've got the area of a circle given. From the area of a circle, ask yourself, what can you find? You can find the radius. Let the radius be r. That's a bit of our algebra again. So area is pi r squared. Do your manipulation. This portion, manipulation. This has to be your habit. It has to be your approach. Start off with a formula. Don't be lazy. Then you manipulate to get the value. From there, use your answer, substitute into the formula again for circumference, pi r squared. So here, you get the answer rounded off to 3SF. Okay, now I'm going to ask you, is this the most exact? Is this the exact answer? Is this answer exact? 31.4? No, it's not exact. Is this better? Yes, this is 5SF. It is more accurate, but is it exact? No, it is not. Why isn't it exact? Because we got a value from 4.9987. Was that exact? No, it wasn't. We got it from square root of 24.987. Square root 24.987 was the problem. That's where the inaccuracy came about. So if we had left it as square root 24.987 and you place it inside here, your answer would be exact. But in terms of square root, well, we don't want the square root, so you have no choice but still eventually have to give us as 3SF. Okay? You are expected to, by default, round it off to 3SF if the answer is not exact. So why is it that in exercise 7, we left it as exact? Because they said leave it in terms of pi. That's how it is possible to leave it as an exact value. Okay, and this is the last question. In the diagram, center of the circle, diameter AC 5 meters, blah, 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 AB 4, BC 3. Find the, leaving in terms of pi again, leaving in terms of pi. You have to get used to this. Leaving your answers in terms of pi. The length of BD. So B to D. Same thing again. Area of triangle, half times 4 times 3, we get 6. Alternative base being 5. With the unknown as the perpendicular height, 2.4 meters again. Same thing, substitute and manipulate. Find the area of the shaded region. Once we have the diameter AC being 5, we know the radius must be radius 2.5. 2.5 meters. Once I have the radius, I can find area. Area of what? Area of circle. And this is a semicircle. Did they say semicircle? Oh, they didn't, but we have a diameter. So of course it's going to be a semicircle. Semicircle will result in half. Yes, half of the area of a circle. Half times pi r squared. See the 2.5? It came from 5 over 2. Minus the area of the triangle. See the, there's an error. Okay, we're not supposed to put it like this. I'm going to change the question slightly when able. Okay, the word necessary a bit ambiguous, right? Necessary, is it necessary? I don't know. You tell me. But if the question says we're able, yeah, I am able to leave it in terms of pi. So this will give us 2.5 square divided by 2, 25 over 8 pi minus 6. So now this is in terms of pi. square meters in terms of pi. But if they did not say in terms of pi, then you round it off to 3SF. Okay? So perimeter of the shaded region. And I think you can do it by yourself already. Everything else the same. Add the different parts together. Then just challenge. Put in terms of pi. Okay, do it by yourself. Next lesson will be chapter 12, part 2 on your parallelogram. You should have already done the video. What's that?